Good morning, students. How are you all? I hope you all are fine. So, today, children, we are going to start a new lesson. Lesson number 12, Study of Sound from Science and Technology, Part 1. So, let's begin. Now, sound. Sound is produced by vibrating objects. The matter or substance through which sound is transmitted is called a medium. This medium can be solid, liquid, or gas. Sound moves through a medium from the point of generation to the listener. Observe this carefully. Now, when an object vibrates, it sets the particle of the medium around its vibration. The particles do not travel all the way from the vibrating object to the ear. So, what exactly happens? A particle of the medium in contact with the vibrating object is first displaced from its equilibrium position. It then exerts a force on the adjacent particle. As a result of which the adjacent particle gets displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process continues in the medium till the sound reaches your ear. Are you getting me, children? So, the disturbance created by a source of sound in the medium travels through the medium and not the particles of the medium. Understood? Okay. Now let's see compression and rarefaction. Air is the most common medium through which sound travels. Yes? When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called a compression or C. Now this compression starts to move away from the vibrating object. When the vibrating object moves backward, it creates a region of low pressure and it is called rarefaction or R. As the object moves back and forth rapidly, a series of compression and rarefaction is created in the air. This makes the sound waves that propagates through the medium. Compression is the region of high pressure and rarefaction is the region of low pressure. Are you getting me, children? Good. Let's see the next. Propagation of sound waves. The sound waves necessarily require a medium for their propagation. The transfer of energy by the waves is through the vibrations of the medium particles about their mean positions. When the medium particles vibrate, there is a change of kinetic energy into the potential energy and vice versa. So, sound waves are also called the elastic or mechanical waves. Now, these mechanical waves are of two kinds: the longitudinal waves and transverse waves. If the vibration of medium particles are along the direction of propagation of the wave, thus forming the compression and rarefaction in the medium, the wave is called a transverse wave. Example: sound waves in a solid and on the surface of a liquid. Transverse waves are formed only in those media which possess rigidity, and that is why they can travel only in solids and on the surface of liquids. A longitudinal wave travels in a gas without any change in heat content of the medium. The speed v of a longitudinal wave, that is sound, in a gaseous medium of density d at the pressure p is given as v is equal to square root of gamma p upon d. Got it, children? Moving ahead, we have the next is that since the density of gas decreases with the increase in temperature and with the increase in humidity in it, so the speed of sound increases with the increase in temperature and with the presence of humidity in the gas. However, the speed of sound is not affected by the change in pressure. Now let's see what are audible sounds. Sounds of frequency between 20 to 20,000 Hertz which can be detected by the human ears. Such sounds are called audible sounds. See children, the limit of hearing of a human ear are 20 Hertz to 20,000 Hertz. That is, the human ear can hear the sound of frequency of this range. So, these sounds are called as audible sounds. Understood, children? Our ears cannot hear sounds of frequency lower than 20 Hz and higher than 20,000 Hz. So these are called as audible sounds. Understood? Let's see the next. Infra sounds. Now children, sounds with frequency smaller than 20 Hz is called infra sounds. It means that sound produced between 0 Hz to 20 Hz. So these kinds of sound are known as infrasound. For example, the sound produced by a pendulum and the sound generated by the vibration of the earth's crust just before an earthquake are some of the examples of infra sounds. Understood, children? Sound which are less than 20 hertz are called as infrasound. Okay, children. I hope you have understood this. Now let's see the next sound, which is ultrasound. Sound waves with the frequency greater than 20,000 hertz are called ultrasounds. Now the frequency of the sound, which is greater than 20 kHz are called as ultrasound. Now the dog, mouse, bat, dolphin, etc. have a special ability to hear ultrasonic sound. Thus, they can sense some noise which are inaudible to us. Children under 5 years of age and some creatures and insects can hear waves with the frequency up to 25 kHz. Bats, mice, dolphins, etc. can also produce ultrasound. So children, sound waves with the frequency greater than 20 kHz are called ultrasound. Understood, children? Audible, infra and ultrasound? Okay, very good. Let's see the next one. The velocity of sound. In any medium at fixed physical condition, the velocity of sound of different frequency is very nearly. The velocity is highest in solids and least in gases. It increases with an increase in the temperature of the medium. Now let's see the velocity of sound in various medium at 25 degrees Celsius. So here is the table of 3 columns. First we have the state, in second column substance, and in third speed in meter per second. So the first is solid. In solid states, the substance we have is aluminium. So the speed would be 5420 meter per second. Nickel 6040 meter per second. Steel we have 5960 meter per second. Iron 5950 meter per second. Brass, the speed is 4700 meter per second. And glass 3980 meter per second. Now in liquid state, the substance is seawater and the speed we have is 1531 meter per second. Pure water 1498 meter per second. Ethanol 1207 meter per second. Methanol 1103 meter per second is the speed. Let's see the next, that is the gas state. The substance is hydrogen and the speed is 1284 meter per second. Helium 965 meter per second. Air 346 meter per second. Oxygen 316 meter per second. And sulfur dioxide 213 meter per second. Okay, let's see the next, reflection of sound. Sound gets reflected from hard surfaces, obeying the law that angle of incidence is equal to the angle of reflection. However, all materials do not reflect sound waves equally. Reflection of sound can be understood by the activity. Let's see the activity. To study the reflection of sound. Now arrange two cardboard tubes in front of a wooden board as shown here. Put a wrist watch at the end of the one tube and listen from the other tube. Adjust the position of the second tube till you hear the tick-tick of watch clearly. You will find that maximum sound is heard when the angle of incidence and the angle of reflection are equal. Understood, children? Okay. Now let's study echo. You must have visited an echo point at a hill station. If you shout loudly at such a point, you hear the same sound just after a little while. Isn't it? This sound is called an echo. And echo is the repetition of the original sound because of reflection by some surface. In order to be able to hear the original sound and its reflection distinctly at 22 degrees Celsius, what must the minimum distance be between the source and the reflecting surface? Yes, at 22 degrees Celsius, the velocity of sound in air is 344 meter per second. Our brain retains the sound for 0.1 second. Thus, for us to be able to hear a distinct echo, the sound should take more than 0.1 seconds after starting from the source to get reflected and come back to us. Are you getting me, children? So, the sound, thus we can determine the minimum distance between the source and the reflecting surface as follows. Distance is equal to speed into time. So, distance is equal to 344 meter per second multiplied by 0.1 second, which is equal to 34.4 meter. Thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is 17.2 meters. As the velocity of sound depends on the temperature of air, this distance depends on the temperature. Now children, the sound heard after the reflection is called echo. We have just learnt this. So metal surfaces are good reflection of sound. But cloth, cork, thermocol and porous materials are bad reflectors. These material absorbs sound. Okay? So these are the bad reflectors of sound. In a large empty hall, we hear echoes only if all the doors and windows are closed and there are no sound absorbing curtains. You must have observed this, children. Even cushions are not there in it. Okay. So, if we stand in front of a tall building more than 11 meters away and shout, we will hear a distinct echo. Have you tried this, children? You must have. So, children, with this, we have finished with today's topic. I hope you found today's topic interesting. So, children, after watching this video very carefully, please read the lesson once to make the concept more clear. So, children, we shall see you in the next video with a new topic. Till then, thank you very much for listening to me, children. Bye. Take care.